Hello and welcome back to our webcast series on the principles of orthographic projection. In this video we're going to look at what to do if you have an object which is made up of the interaction between different shapes. So looking at the example that we have here we see an object where we have three different shapes. We have this block being added to this slope piece, and we also have the interaction between this curved piece being subtracted from our slope piece. So these are interaction between three different shapes, and this is an area which can cause students starting off with a bit of difficulty trying to work out the missing information from the questions. So hopefully this video is going to shed some light on how to go about solving these questions. So to start with, we're just going to look at a background concept which we're going to use to solve these questions. That's the concept of a contour or a profile view. Now a contour is an outline representing or bounding the shape or form of something. And a contour view then is basically the view which identifies the shape of the object where it's seen as an edge. So if we look at the example of a house, here's the front elevation and plan view of a house. From these two views here, we don't know if maybe the back of our roof here, if that's flat or if that's sloping. So we need more information in order to determine what the real shape of the object is. So if we were to look in from the side and take an end view, well, in the end view we can see the two surfaces as an edge, and we see the true pitch or the true angle of our roof surfaces. So in this case the end view is our contour view, so it's the view that tells us the real shape of the roof. Likewise, if we look at a couple of examples, here's one where we have the front elevation and the end view of an object, and apart from the fact that it's shaded and we have our center line here, we don't really know what the shape of that object actually is. So we need to have more information. So in this case our plan view here tells us that it's actually a cylinder we're dealing with. So the plan view here is the view that tells us the real shape of the object. That's our contour view. And let's look at another example here where we have the front elevation and the plan view of an object. Now neither of these views are contour views, and really without the contour view we can't fix this as one particular shape. Some people could see it as a Toblerone box laid flat, so a triangular prism, but you could also say that it's a block with the front surface kind of sloping, and both those cases would be correct for the two original views. We need to have our contour view before we know what the real shape of the object is. So that's what a contour view is. The next thing I want to look at is how do our different shapes interact with each other. And the general rule is that if we have two shapes interacting, they do not affect the contour view of each other. So if you have two shapes, the contour view of each of the shapes will remain the same whether there's an interaction or not. So we'll just illustrate this with this example. Here we have a block with a sloping surface, so this yellow surface here. Here we have the front elevation, here we have the plan, and here we have our end view, which is our contour view for our sloping surface. Okay, so that's our first shape. The second shape we're going to have is going to be a notch taken off the front of it. So we're going to take our slope here. Here we have 2D, here we have it in our 3D, and we're just going to remove the front piece of the block. So that's going to create this red surface here. So just taking a close look at it, here's our finished end view. The plan view is going to give us the contour view of our slope or our notch. So that's our notched shape is seen as a contour view here in our plan view, and our end view is giving us the contour view of our slope. Now if we look at our notch and take it across into our end view, we can see that the slope surface hasn't been affected by the fact that our piece has been notched. This line here, this edge view of our yellow surface has remains the same whether it's been notched or hasn't been notched. And this is important because a really common mistake that a lot of students starting out will do is when they try and draw this shape here, they expect to see a change of direction, something like this. And the reason for that is that when you look at the 3D, if you look at this edge here and this edge here, you see a change of direction. So students try and emulate that or trying to draw that in, but in actual fact that's not correct. In actual fact, the yellow surface here, whether it's been notched or not, hasn't changed. So we expect to see that as a straight line whether it's notched or not. Likewise, if we look at our notch in our plan view, whether this yellow surface here is sloping or not sloping has no effect on our edge here like that. So the contour views remain unchanged by the interaction. Now, if we look at our view here, our front elevation, this view then isn't a contour view for either of the shapes, so this view here is going to be basically a combination of the two. So that view will be changed, and we need to have our contour views solved first of all to bring them in, to combine them in this view. So we can see that been done here. We can just take our point across, our point up, and here we have the combination of the two. So we're going to look now at just a procedure to help us solve this type of question. So the procedure itself is quite straightforward. First of all, we want to just identify the individual shapes, and just as a handy tip, generally label them on the question itself. Generally the question is given to you in a 3D form, so just label it on the question. Second thing we want to do is work out what view, or where do we have to look at the object to see the contour views of those two, the different shapes. The next thing then is identify any lines or curves that are a result of the interaction of the different shapes. And then lastly, to locate these lines or curves, find them on the contour view first, and then bring them in to the missing view. And a handy little tip there, as always, if you label up the points, it makes life an awful lot easier. So let's just take an example. So this is a past junior cert question. So here we have an object made up of a combination of different shapes. So we're going to see how to put the procedure into action to solve for any missing part of the question. So looking at our object, first thing we're going to do is identify the individual shapes. So looking at the 3D, we have our block shape part here, which is we're going to call number 1. We have our sloped portion here, which we're going to call number 2. And we have this curved piece, which is taken away from our slope piece. So we have 3 different shapes here, all interacting with each other. The next thing we're going to do is identify, well, where do I need to look at this object in order to see the contour of each of these shapes. So if we take the block piece here and the curve, well, if I look from above, I'll see the true angle of that, and I'll see the true curve of this here. So the plan view will be my first view to create, and from your question you'll have all the information to set that up. The next thing we want to do is look at our remaining shapes. So this slope shape hasn't been dealt with, so we need to look in from the side in order to see that contour. So we're going to draw in our end view then as our next object. So there's our end view. We're going to then just combine the two together. So if we look at, say, our edge here, well, we have that in our plan view, so we can bring him across and locate it in our end view. Likewise, our corner here from where our curve hits the end, we can take that across and up, and that'll give us that in our end view like that. So that's actually our plan view and our end view entirely completed with the information that we've given at the start of the question. The next thing we want to do then is just complete what we have of our missing view, so our front elevation. So from the question we can fill in as much information as we can from the dimensions given. Then we want to work out, okay, what are the parts that we have to go and find? We have to work out these, and these are the lines that are as a result of a combination or an interaction between the two shapes. So on our object here, we have this curve here, and we have this line here like that. So let's work out the line first of all. The general rule is locate the line or curves, locate them on our two contour edges first, and then bring them together in our views. So if we look at, say, this corner here, we have this point at the bottom. There he is here. Let's locate this point here. So first of all, we find it on our contour view for our block piece. Here we have it as X. Then we bring it across and we locate it on the contour view of our slope. So here we have it here, X. And then we bring the two together to find our missing information in our missing view. So there is that line found from bringing our two contour views together. Same thing applies with the likes of our curve. If we break the curve up into a number of equal parts, and again, labeling them always makes life a little bit easier, well, we can locate our point on each of our contours. So let's take point 0 to start with. So 0 is located here on our curved contour. We can bring it across, and here we have it located on our sloped contour. Then we can bring the two together to find it in our missing view. Same thing applies with number 1. Find it on our curved contour, bring it across, find it on our sloped contour, and then bring the two together. Same thing again with number 2. Here it is in the curved contour, on the sloped contour, and bring the two together. Same thing lastly with number 3. There it is in the curved contour, there it is in the sloped contour, then we combine the two together. And all we have to do then is just basically join the dots, so either freehand or using a flexi curve or a French curve, you can just fill in the curve like so. So that's all the missing information in our final view brought together. So just add it to our 3D drawing, and that's the question completed. So that is a full junior cert question, and if you look back over the likes of the junior cert questions, every single question is just a combination of different shapes interacting with each other. So if you can identify the shapes and follow that procedure, there's no question which can throw you really. So as always, I hope this has been of some use to you, and hopefully we'll see you again for some more of the videos. So take care.